All right, so we are still in the logarithms chapter, and today we'll be covering radioactive decay. All right, so we will be dealing with half-life. Okay, as an example, the substance bismuth-210 has a half-life of 5 days. Okay, so let's say you started with 16 grams of bismuth-210. All right, if the half-life is 5 days and you start with 16 grams, it's going to decay to 8 grams of bismuth-210 and 8 grams of another substance. Okay, and then after another 5 days, it's down to 4 grams. After another 5 days, it's down to 2 grams. All right, so we can use logarithms and the half-life to find the rate of decay. We will use the decay formula. N of t equals n sub 0 times e to the negative rt. All right, so we'll get to that in the problems. I'll show you a little t-table real quick for the half-life of bismuth-210. All right, so bismuth-210 has a half-life of 5 days. So in their example, the amount they started with 16 grams. All right, 16 grams, and that's on day 0. And then within 5 days, it's cut in half to 8 grams. All right, and then another 5 days, which is 10, it's cut in half to 4 grams. Okay, and finally another 5 days, it's cut in half to 2 grams, and so on. All right, so we can see this is not linear. As the number of days increases by 5 each time, the amount is not subtracted by the same number each time. It is multiplied by 0.5 or 1/2. All right, so it's actually an exponential equation. All right, because you're not adding or subtracting the same number, you're multiplying the same number each time. So that is an example of half-life. All right, example 1, they want us to find the daily decay rate of bismuth-210. All right, they gave us in the write-up for bismuth-210, the half-life is 5 days. So they said we are using the decay formula. All right, so since this substance is decaying, this is going to be a population decay. All right, so it is the same as population growth in that it's going to be n of t equals n sub 0 times e to the negative rt. Okay, so instead of positive rt, since we're doing decay, it's negative rt. All right, this is actually similar to the present value formula. When you find the present value, it's a times e to the negative rt. All right, so it's basically the same formula. Anyhow, since the half-life is 5 days, we can say that the original amount is cut in half every 5 days. All right, so I showed you that on the t-table. The original amount is cut in half every 5 days. So let's see, we want to find the decay rate, that's R. And we know the original amount is cut in half every 5 days. So what does that mean? See if I have room here. I'll write it underneath right here. If the original amount is cut in half every 5 days, we can say that at t equals 5, n of t equals half of n sub 0. Okay, really I should say n of 5 instead of n of t. But really, let me see here. Okay, that's actually correct. At t equals 5, n of t equals half of n sub 0. Okay, remember the original amount is n sub 0. Okay, n sub 0 equals the original amount. Okay, and the original amount is cut in half every 5 days. So at t equals 5, the original amount, which is n sub 0, is going to be cut in half. So n of t equals half. All right, so in place of n of t, since n of t is half of n sub 0, I am going to take that and plug it in place of n of t. All right, so n of t is going to become 1/2 n sub 0, and that's going to equal n sub 0 times e to the negative RT. All right, and let's see. For the time t, we're plugging in t equals 5, so let me cross out the t and write a 5 here. Okay, and we're solving for r, the exponent. The r is in the exponent of e. All right, and that exponent is not applied to the n sub 0, so we need to divide both sides by n sub 0. All right, n sub 0 is just a number, but we don't need the actual number because we're going to get rid of n sub 0. All right, so divide both sides by n sub 0. It cancels on the right, and it cancels on the left. And we are left with 1/2 equals, and leave some space, e to the negative r times 5. So it's just negative 5r. Solving for r, we have a base of e, so we want to use log base e, or the natural log, on both sides of the equal sign. Okay, natural log of e just cancels, and you're left with the exponent. So negative 5r equals the natural log of 1/2. Finally, the opposite of times negative 5 is divided by negative 5. Okay, and it cancels on the right. Let's go to our calculator. ln of 1/2 divided by negative 5. All right, ln of 1/2, close parentheses, divided by negative 5. Hit equals, and I'll do 4 decimals, 0.1386. All right, recall the units on the exponent, r and t, have to match. So t equals 5, that was in days. Okay, remember the half-life was 5 days. So the time t was 5 days, and that means this rate r is per day. So converting this to a decimal, if you move it over 2 places, that's going to be 13.86. and that is per day. All right, example 2, the half-life of radium-226 is 1,600 years. What is its annual decay rate? So, the half-life is 1,600 years. That means that N of t is going to equal half of the original at t equals 1,600 years. All right, so the 1,600 years is your t, and the annual decay rate is the r. We don't know what r equals. So again, I'll just label it up top. This is a population decay. All right, the population or the amount is decreasing. So I'm going to use that formula, N of t equals n sub 0 times e to the negative rt. All right. So we said the N of t is half of the original at 1,600 years. So this half of n sub 0 is getting plugged in for N of t. And that's going to equal n sub 0 times e to the negative r times t, which is 1,600. All right. If the time t is in years, it will give you the decay rate per year, or the annual decay rate. All right. That's what annual means, per year. So let's see. We have n sub 0 on both sides. As always, the exponent is with your e, but it's not with the n sub 0, so we want to get rid of that. All right, so the opposite of times n sub 0 is divided by n sub 0. All right, it cancels on the right, and it also cancels on the left. We are left with 1/2 equals e to the negative 1,600r. All right, and since our exponent is on the e, log base e, that's the same as the natural log. All right, natural log of e cancels, and you're just left with the exponent. All right, ln of 1/2 equals negative 1,600r. In other words, negative 1,600 times r. All right, the opposite of times negative 1,600 is divided by negative 1,600. On the right, it cancels. Same term over itself. ln of 1/2 divided by negative 1,600. Let's see. All right, hit clear. ln of 1/2. Close parentheses divided by negative 1,600. And we have point. I'll do 3 decimal places after the zeros. 0.000433. All right, it was negative 0.000433. Converting to percentage. Move the decimal over 2 places. 1, 2. All right, so it's going to be 0.0433. Negative 0.0433. That is in terms of percentage, and that is annually, so it is per year. All right, last one. Suppose a radioactive substance decays at a rate of 2.5% per hour. What is its half-life? All right, so the rate of decay is 2.5%. But if you move the decimal over 2 places, that is going to be 0.025. Okay, and that is per hour. So I'm just going to write a slash with HR, per hours, per hour. Anyhow, this is a population decay. All right, so we're going to use the same formula we've been using, n of t equals n sub 0 times e to the negative RT. All right, so we want to find the time. We want to find the half-life, that is the time t. All right, and it's going to be in hours if we plug in the rate per hour. So at the half-life, n of t is going to be half of the original. At the half-life. All right, for t equals whatever. So we're going to plug in 1/2 n sub 0 in place of n of t. All right, in place of n of t, 1/2 n sub 0, and that equals the original amount, n sub 0 times e to the negative r, which is 0.025 in place of r, times t, which we don't know. All right, so we don't need the original amount because we are going to divide both sides by the original amount, n sub 0, and get rid of it. Okay, it cancels on the left, and it cancels on the right as well. And we are left with 1/2 equals, and leave some space, e to the negative 0.025 t. All right, so log base e, as we've been saying, is the same as the natural log. That's why we're going to do natural log in order to isolate that exponent. We're going to do natural log on both sides. Natural log of e cancels, and we are just left with the exponent. All right, so we have the ln of 1/2, and that equals negative 0.025 t. All right, so t is multiplied by negative 0.025, and the opposite of times that is divided by that, negative 0.025. You do that on both sides. On the right, the same term divided by itself cancels. We are left with t. I'm going to go to the calculator on this. All right, natural log of 1/2 divided by negative 0.025. Hit equals, and let's see, if I do 3 decimals, 27.726. All right, so what are the units on t? Well, we said before we did the rate per hour, so this is in hours. And let me see something real quick. All right, this was not negative. I don't know why I put that there. So that was in hours. And that's basically it. If you wanted to round off a little more, I would probably just say 27.7. But that is your half-life.